Hello and welcome students. Welcome to Unacademy, India's largest learning platform. Okay. So myself Sunil Manjani. I have got 15 plus years of teaching experience. I have mentored thousands of students for GATE ESE and semester exams as well as MATLAB. Okay. I have cracked PSU exams like GATE, HL, MAR, DISCOM, Mahajanico. So you can see that how to use Unacademy learning app. Okay, go to step 1, go to step 2. Okay, in step 1 you will install this Unacademy learning app. Okay, after searching in step 2, press the install button. In step 3, after allowing all the permissions and registrations, go to manage goals. Okay, click on GATE ESE, click on then plus subscription in step 4. Okay, click on get subscription button. Okay, now again you will be clicking, you have clicked on plus subscription, but there is another subscription called iconic also. Okay, 12 month subscription for plus will cost you 27 to 25, and 24 month subscription will cost 39,600. So iconic subscription 12 month package is of 45 to 25 and 24 month package subscription is of 66,600. Of course you can get further 10% discount in all the courses. Okay, if you use my code SSM10. What is plus? India's best educators educate you. Interactive live classes are there. Okay, structured courses and PDF live tests and quizzes. Iconic best educator educate you. That means this all you can see are plus subscription features. Okay, in addition to that you will get personal coach, personalized test analysis, study planner, proprietary study material. Okay, for yourself. So let us continue with our course, that is MATLAB fundamentals. Yesterday we did some big program. Okay, on presentation. Today we are going to do that in actual MATLAB environment. Okay, so let us move on to our MATLAB environment. Let us select, so clear all, select script file, CLC. Okay, so what was our example? Our example was GS equal to 25 by S square plus 2.5. Okay, S square plus 2.5. Okay, so if you remember that, okay, so I will say NFP means forward path, numerator is 25 rather. Okay, okay, DFP is equal to 1 space 2.5 space 0, or rather I will say it is not like that, it is 1 space 0 space 2.5. Okay, this is DFT. Okay, then I will say N1 comma D1 is equal to this is a unity feedback system. Okay, these are the NFP and DFP are forward path. Okay, forward path gain. Okay, if I say this is feedback path gain, feedback is unity feedback is HS equal to 1, that is 1 upon 1. So NFB feedback numerator is equal to 1, isn't it? Then denominator of feedback is equal to 1 also. 1 by 1 is 1. So it is a unity feedback system. Okay. So I'll say N1 comma D1 is equal to feedback NFP comma DFP. Comma 1 comma 1. Sorry, instead of 1 1, what I will write down, let us see. NFB comma DFB. Okay, so this will give you overall transfer, overall numerator and denominator. Then I will say system 1 is equal to transfer function N1 comma D1. N1 comma D1. Fine. Okay. So let us see that. Okay. With this function, how we can. This is the overall function of closed loop transfer function. Closed loop transfer function of unity feedback system. Okay, what is given is delay time is given for derivative feedback. TD, time constant is given. Okay, time constant was not given. We had found out yesterday TD was equal to 0.293. 0.293, that was TD. Okay, that was TD. What was numerator, denominator? This is 1 plus TDS. 1 plus TDS is the transfer function. 1 plus TDS or STD plus 1. So what is numerator? Terms of S, this is TD and space 1. Space 1. Okay. So let it come up. Okay. space 1, TD space 1. What was denominator? DD. That is for derivative controller. TD is, this is S term is 0, only constant was divided by 1. So S term was 0, constant is 1. So this is your, okay. Constant is 1. Constant is 1. So this is constant, okay. Then I will say system derivative, sys d, is equal to transfer function of derivative controller, that is nd comma dd. nd comma dd. So okay, so now this derivative controller is in series with the system transfer forward gain. So I will say that ns space ds is equal to series forward gain nfp, that means numerator of forward gain comma denominator of forward gain comma numerator of derivative controller comma denominator of derivative controller. So this is your series connection of derivative controller with the forward gain. Okay. So overall transfer function, this was sorry. This was for without derivative controller. This is with derivative controller. This is forward gain. Okay, this is forward gain series. Okay, so when I am saying control X, let us see. First of all, this is series connection of TD plus S and GS. Okay, this series connection is in feedback with unity feedback control loop. So I will say sys FP forward path, or I will say sys S is equal to transfer function ns comma ds. Now I will say n2 space d2 okay. Okay, N2D2 is equal to, now feedback, okay, what it will be, feedback of what, NS comma DS comma NFB comma DFB, feedback loop closed. Okay, so this will be for with derivative controller. So overall transfer function with derivative controller. Okay, so this will be sys2 is, sys2 is equal to, okay, transfer function n2 comma d2. Okay, this is with derivative controller. This is one file. This is one file. Okay, so this is one file. So let us see if we can write down the program. Okay, okay, so what I will write down, we have to compare the step response. So step, before that I will write introduce figure 1, figure 1, figure 1. Okay, step sys1, what was sys1? See here, sys1 was transfer function without derivative control. Without derivative control. Then I will say grid on. Okay, grid on. Figure 2, I will say step with derivative control is sys2, step sys2. Okay, so let us see. Okay, again I will say grid. Let us see. Let us save this. Comparing, comparison. Okay, I will save it comparison. So let us run this one. Oh, sorry. So let us wait for the figure to be. Okay, this is step 2. This is step 1. This is step 2. This is step 1. Okay. What is system 1? Let us see. What is system 1? 25 upon a square plus 27. This is system 1. Let us see system 1. Let us check first once again. System 1. N1 comma D1 without feedback controller. Okay, without feedback controller. So let us check first of all what should be system 1 transfer function. So without feedback GS was 25 S square plus 2.5 this is GS. HS is equal to unity feedback. This is equal to 1 upon 1. For unity feedback system, overall transfer function is GS upon 1 plus GS HS. Okay, let us see. This is 25 upon S square plus 2.5 divided by 1 plus 25 upon S square plus 2.5. That is equal to 25 divided by S square plus 2.5 divided by s square plus 27.5 divided by s square plus 2.5. So these two gets cancelled. This is 25 upon s square plus 27.5. Okay. With feedback controller, sorry, with the derivative derivative controller transfer function is 1 plus TDS. Okay, so with the derivative controller, this is GS, this is 1 plus TDS, this is equal to HS. This is equal to HS plus minus RS. This is equal to CS. Okay. So with this controller, okay, with this controller, okay, what is overall transfer function? 1 plus TDS GS divided by 1 plus HS into 1 plus TDS into GS. So that is equal to 1 plus TDS 25 upon s square plus 2.5 divided by 1 plus TDS 25 upon s square plus 2.5. So this is equal to s square plus 25 TDS plus 2.5 divided by s square plus 2.5 plus TDS cube. S square plus 2.5 plus TDS plus 25 TDS. So if I say this is equal to this is like this. So this numerator will change, sorry. Let us change this function. Okay. So this is 25 upon s square plus 22.5 2.5. Okay. S square plus 2.5 plus TDS or 25 TDS divided by s square plus 2.5. S square plus 25 TDS plus 2.5 divided by s square plus 2.5. This will get cancelled. This will be 25. Okay, 25 1 plus TDS divided by s square plus 25 TDS plus 2.5. So in this way you will get the transfer function. Okay, in this way you will get the transfer function. Okay, so the plots obtained, you can see that s square plus 27.5 Quite clearly there is no S term, therefore it is quite a bit oscillatory response. Quite a bit oscillatory response. Okay. But when you introduce a derivative controller, the response is less oscillatory. It will settle down very quickly. So what is the function of derivative controller? To further damp the oscillation. To further damp the oscillation. So this is called as one great example for this function. Okay. So this was our example. Okay. So let us come now to some. Okay. So let us move on to another problem. Okay. Let us see example. This is third part of our series of step frequency response using MATLAB. Okay. So let us go to example. Okay. So GS is equal to 1.6. Okay. GS equal to S square plus okay. Damping ratio is equal to 0.6 is desired through derivative feedback. Derivative feedback. Feedback control, or rather derivative control. You have to determine value of time constant TD and compare rise time, peak time, maximum overshoot, settling time, settling without and with derivative control. Next, okay, we'll write down the program. First of all, GS is equal to 16 upon S square plus 1.6. Feedback is equal to 1 by 1, that is equal to 1. Okay. So without derivative controller, let us see the diagram. This is equal to GS, this is equal to HS, this is negative, RS, CS, RS and CS. Let us see, okay, what is RS? Sorry, what is transfer function? Transfer function is equal to rather closed loop. GS upon 1 plus GS HS. Finish? Okay. Now let us say closed loop transfer function is equal to 16 upon S square plus 1.6 divided by 1 plus 16 upon S square plus 1.6 into 1. That is equal to 16 upon S square plus 17.6. This is closed loop transfer function without derivative controller. With derivative controller, okay, closed loop transfer function is equal to numerator will be series of 1 plus TDS into GS divided by 1 plus TDS into GS into HS. So this is equal to 1 plus TDS GS, rather I will say 1 plus 16 upon S square plus 1.6. This is GS, 1 plus TDS divided by, oh sorry, this will not be there, divided by 1 plus TDS into 16 upon S square plus 1.6 into 1. So this will be equal to 16 into 1 plus TDS, okay, upon S square plus 1.6 plus 1 plus TDS into 16. That is equal to 16 1 plus TDS upon S square plus 1.6 plus, sorry, yes, plus 16 TD into S. That is equal to 16 plus 16 TDS divided by S square plus S into 16 TD plus 17 points. Okay, plus 17 points. Okay, so now let us compare with standard form. What is standard form? Closed loop transfer function is equal to omega n divided by S square plus 2 zeta omega n S plus omega n square. So comparing okay, so comparing 2 zeta omega n is equal to 16 TD, omega n square is equal to 17.6. So zeta omega n equal to 8 TD, zeta square omega n square is equal to 64 TD square. Zeta damping ratio is given as 0.6 whole square. Omega n square is 17.6. This is equal to 64 TD square. Let us say TD square is equal to 0.6 square into 17.6 divided by 64 divided by 64. Okay, so let us see if I use my calculator. Okay, 0.6 square, 0.6 into 17.6 divided by 64. This is equal to 0.099, that is equal to 0.1 TD square. So what will be TD? Let us say so TD is nothing but under root of 0.1, 0.316 seconds. So this is 0.316 seconds. So this is value of derivative time constant. Okay. Now without feedback. Okay. And this will be with feedback. Let us compare through MATLAB programming with derivative controller. I'm sorry, not feedback, derivative controller. Okay, so with derivative controller, with without derivative controller. This is feedback function, isn't it? Isn't it? CS plus minus. Okay, so what I will do is, first of all, numerator of G is equal to 16. Okay, because GS is equal to 16 upon S square plus 1.6. Denominator of G is equal to 1 S square term, no S term, constant term. This is NS. NH is equal to HS is equal to 1, which implies 1 upon 1. Numerator term is 1. Denominator of H is equal to 1. Then these two are in feedback. These two are in feedback. Okay. So I will say without derivative controller, that means N1 space D1 is equal to feedback GS value NG comma DG comma NH comma DH. So N1 is equal to okay. So this is your okay. Then this one is equal to transfer function N1 comma D1. N1 comma D1. This is the program. This is the program. What we have to do is in this program we have to determine the time response. We have to determine time response. Okay. Time response specification we need to determine. We need to determine what? See here. Determine, compare rise time, peak time, maximum overshoot and settling time. Rise time, peak time, settling time, maximum overshoot. Maximum overshoot. Okay. So this is our program. Okay. Now let us see. We will write down about controller. This controller. One plus STD GS HS. Derivative controller ND. Derivative controller DS is equal to 1 plus STD, that is STD plus 1. S factor is TD. Constant term 1. This is divided by 1. Denominator DD is equal to S term 0, constant term 1, like this. Okay. Then these two are in series. These two are in series. So I will write down forward path NF DF is equal to series NG DG comma ND DD comma ND DD. This is the part. Let us come down to next program. Next part of the program. Okay. After these two are in series, this is in feedback. This is in feedback. So I will say N2 with derivative controller D2 is equal to feedback. Feedback of what? This series combination and HS. Series combination is NF comma DF. For HS NH comma DH. NH comma DH. So this is the series combination of the system. Excuse me. Okay. N2 D2 feedback NF DF NH DH. Okay. So now what I will write down? Okay. System 2 is equal to transfer function N2 comma D2. Okay. So this will give me transfer function with or without feedback. With or without feedback. Let us see. Let us see with and without feedback how I can use it. With and without feedback. Okay. This is without feedback. This is with feedback. With feedback. Not sorry. Without controller. Control. Okay. Let us say this is with controller. Control. Finish. Okay. So now we will compare. Okay. So I will say that for comparison of both the function, so I will say that step info system 1, okay, and step info system 2. In this way I need to find out. In this way I need to find out. Okay. So Let us see. Okay, so in this way we will compare. Let us do hands-on for this. Let us do hands-on for this. Okay, let us copy this code similar to this example, so it will save our time. Similar to this example, Control C. Let us do Control V. Okay, here I will say ng is equal to 16, dg is equal to 1, 0, 1.6. Okay, here nh equal to 1, dh is equal to 1. Okay, so I will say ng dg nh dh. Okay, td was equal to 0.1, isn't it? So let us see. Let us verify once again. TD was 0.316. Sorry. TD was 0.316. Okay. ND, are same. Okay. System transfer function with derivative control is ND, Okay, no problem. This is NG. This is DG. NDA. DD series controller. Okay. Then feedback. Let us see that program will be written down. Okay, program will be written down. NFDF is series. Okay, then let us see this. NFDF is series. Okay, then we'll write down this as NFDF. N2D2 is NFDF. NH DH feedback. Okay, so this step info will not give us a figure, so I will say that step info, this one, no grid on because there is no figure. Okay, no figure 2, there is no figure. Step info, no grid on. Okay, so save this. Comparison to. Okay, we are not saving in an academic folder, we are saving as it is. See here now. See. Without feedback control, we can write down one more function here. Okay, display characteristics without controller. Okay, control C, control V, characteristics with controller. Okay. See, peak is infinity, rise time is very less, very high, not a number. So you can see that, okay, you can see that how the parameters are controlled here. Parameters are controlled. So again, I will just write down characteristics with controller, okay, characteristics without controller. So you can see the difference. You can see the difference. Okay. So this is okay. So now see one more example. Okay. We'll cover some step response. Okay. So G, so one transfer function is there. It is defined as s plus 30 divided by s square plus 8s plus 15. This is transfer function 1. Transfer function 2 is equal to 16 upon s square plus s plus 16. S square plus s plus 16. Okay. So we'll write down some program. In the meanwhile, we'll write down. We'll follow with the with hands on. Okay. Let us say n1 is equal to 1 space 30. d1 is equal to 1 space 8 space 15. n2 is equal to 16. d2 is equal to 1 space 1 space 1 space 16. 1 space 1 space 16. This is d2. Okay. Now we will say system 1 is equal to transfer function n1 comma d1. System 2 is equal to transfer function n2 comma d2. Okay. Now next step we will write down what is the step response. What is the step response? This was transfer function. Transfer function. So let us write this transfer function. Sorry, step response. So step response is given by the step sys1. Okay, step if I want them to appear in separate figures, separate plots. If in same plot, I will write down step sys1 comma sys2. This will be in same plot. Okay, so this is in same plot. This is in same plot. Okay, next is frequency response. Frequency response. Let us calculate. Let us do the command for that. We have learned magnitude, comma phase, comma frequency is equal to body system. Okay, M is equal to magnitude row, all rows and column. P is equal to phase, all rows and column. Okay, similarly I will say mag 2, phase 2, frequency 2 is equal to body sys 2, M2, mag 2, P2, phase 2, column, then semicolon. Okay, then we will say frequency response from 0.1 to 1000 radian per second. Let us say its syntax. Frequency is equal to log space -1, 3. How this comes out to be? See here. How this comes out to be -1, 3. This is 1, 10, 100, 1000, 10,000, like this. 1, this will be, I will say, this will be 1 into 10 raised to the power 0, 1 into 10 to the power 1, 1 into 10 to the power 2, 1 into 10 to the power 3, 1 into 10 to the power 4. This after this 1 into 10 to the power -1, that is 0.1. So you can see that this 0.1 is 1 into 10 to the power -1. This 1000 is equals to 1 into 10 to the power 3. So log space, first one is -1, Next argument is 3. So frequency is like this. Okay. So I will say magnitude comma phase is equal to body system 1 comma frequency. M1 is equal to magnitude P1 is equal to phase. Okay. Magnitude 2 phase 2 equal to body phase 2 comma frequency. M3 is equal to magnitude 2 P3 is equal to phase transfer function. Next one is transfer function manipulation. Function manipulation. Okay. So A part, two transfer function in series. So we are seeing this S is equal to series sys underscore S series sys1 comma sys2. Sys1 comma sys2. Okay. So this is the series transfer function. This is series transfer function. B, two transfer function in parallel. Sys P is equal to parallel sys1 comma sys2. Sys1 comma sys2. Okay. And this is the one response. Okay. Then we will say third part. Two transfer function, or rather transfer function in feedback loop. Feedback loop. Let us say this underscore f is equal to feedback sys1 comma sys2. Okay. Next one is feedback using algebra. This is to cancel equal poles and zeros. So let us see how to get this. Let us see how to get this. So feedback is equal to this one slash 1 plus this one star this 2. Okay. Then again feedback is equal to min real feedback, as I will say min real feedback. Okay, so we will do these two in hands-on session, these things in hands-on session. Okay, these things in hands-on session. Okay, so let us do. Okay, let us do. N1 is equal to 1 space 30. N2 is equal to, sorry, D1 is equal to 1 space 8 space 15. This is our D1. Okay, sys1 is equal to transfer function n1 comma d1. Okay, n2 is equal to 1 6. d2 is equal to 1 1 16. sys2 is equal to transfer function n2 comma d2. Okay, so this is your transfer function. Now step response. Okay, step sys1. Okay, let us repeat the step. Okay. Next is step SYS2. So you can see the okay. Next step is let us do in single plot SYS2 SYS1. So blue one is SYS1, this one is SYS2, red one. Okay. Then let us see frequency response. Okay. Mag 1 comma phase 1 comma frequency is equal to bode sys1 bode this bode this one. Let us repeat this. Let us say bode sys1. So this is a bode diagram. Okay. So let us compare minimum stability margin. Okay. Closed loop system stable. Okay. Don't need to compare this magnitude and all that. Okay, don't need to do it. Okay. Then we will write down frequency range. Okay. So frequency is equal to log space minus 1 comma 3 minus 1 comma 3 magnitude comma phase is equal to bode sys1 comma frequency. Okay, sys1 comma frequency. So you can get the magnitude and phase plot also if you say bode only. Okay, so this is bode. You can use Bode for sys2 for sys2. Okay, so let us see the stability of this. Okay, stable. Okay, so transfer function manipulation, let us say series is equal to series 1 star series 2. Oh, sorry, sys 2. This is sys 1. Okay, let us say series S is equal to series sys 1 comma sys 2. So you can say, you can see there is a difference between the transfer functions. Between the transfer functions. Okay. In this way, you can also say some parallel and then feedback like this. Okay. So we will not do that. Okay. So let us go to our PPT. We will straight away jump on to analysis. Straight away jump on to our analysis. Let us see what is the analysis. You want to get numerator and denominator. Get numerator and denominator. So what we will do here, what was our system? Our system was feedback system. Okay, so we have to execute this command. So I will say feedback is equal to feedback sys1 comma sys2. fb1 is equal to min real fb. Okay, I want to get numerator and denominator. N comma d is equal to transfer function data fb1 FB1 comma in quote V, okay, n is equal to FB1 dot num1, D is equal to FB1 dot FB1 dot denominator 2, sorry 1, okay. So let us do it hands on. FB is equal to feedback sys1 comma sys2, okay. FB1 is equal to min real FB, min real FB, okay. N comma D is equal to TF data FB1 comma port V, okay. N is equal to FB1 dot num1, okay. D is equal to FB1 dot denominator 1 dot denominator 1, okay. In this way you will get the answer, okay. I want to write down some poles of a transfer function, okay. Let us go to analysis again. Poles of transfer function, poles of transfer function. So what is the answer? What is the solution of it? Roots first of all D, then damp D, then damp FB1, 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 okay. So this is how you get the transfer function, okay. Let us do hands on. What are the commands? Roots D, damp FB1. So roots D, damp D, pole, okay. Damping frequency time constant, okay. So this is how you get the time constant, okay. Next is, what was next? Damp FB1. So pole, damping, frequency radian per second, time constant you will get. Okay, for different poles. Okay. Okay. So this is okay. Okay. Then there is a LTI view. Okay. So you know that LTI viewer also you know that. Okay. So next one, let us see. Next one is equal to inverse Laplace transform. Inverse Laplace transform. Okay. So this is what? Okay. You find n1 comma d1 is equal to TF data sys1 comma quoted v. Sys1 comma quoted v. Then RPK root pole gain is equal to residue n1 comma d1. N1 comma d1. R is equal to like this. Okay. Let us say that we will do the hands-on. N1 comma d1 is equal to TF data sys1 comma v. Okay. Let us say R comma P comma K is equal to residue comma d1. Okay. Let us come to symbolic manipulation. Symbolic manipulation. It is very interesting. Okay. Manipulation. Declare S as a symbolic variable. NLS is equal to polynomial to symbolic n1 comma s. DLS is equal to poly to symbolic n2 sorry d1 comma s. Okay. H is equal to simple NLS comma DLS. Okay. So this is the one thing you can write down. We will do hands-on on this. Okay. Symbolic sims s. Okay. This is only declaration. This is only declaration. Okay. NLS is equal to poly to symbolic n1 comma quoted s. Sims s NLS equal to poly to symbolic n1 comma s. DLS is equal to poly to symbolic d1 comma quoted s. Okay. H is equal to simple NLS slash DLS. Okay, so in this way you can find out. Okay, find out the symbolic. You can also find out inverse Laplace transform. I Laplace H. So suppose you want to find out step response. Step response to H. H is the transfer function. Step response will be what? Cs equal to Hs into Rs. Step response Rs is equal to 1 by S. So this is equal to Hs into 1 by S. Step response. Then you can find out Ct. That is I Laplace Cs. Let us do hands-on. Okay. Let us do hands-on. Step response, not DTP, STP. Step response is equal to 1 by S star H. So this is your step response. Step response time t is equal to I Laplace step res. Okay. You can plot the function also. 0 colon 0.01 colon 5. This is t variable. Y is equal to eval vectorize STP res capital vectorize. Okay, so plot t comma y. This is your step response. Okay, let us move on to other part, that is manipulation of transfer function. Manipulation of transfer function. So let us say symbolic G H K small k. G is equal to 1 S square plus S plus 16. H is equal to K into S plus. Okay. So transfer function is equal to G upon 1 plus G star. Okay. Then simplification. Simplify transfer function. Okay. K is equal to 10. Okay. T is equal to simple transfer function. T is equal to eval T. Okay. Eval T. Then you will say that pretty T. Pretty paste. Oh, sorry, bracket. So let us do it hands on. Sims is equal to, or I will write down in this file also, G comma H comma K, or you can say G space H. Sorry. Okay. G equal to 1 divided by S cap 2 plus S plus 16. Okay. H equal to K star S plus 1. Okay. Transfer function is equal to TF is equal to G divided by 1 plus G star H. Okay. G star H. So you will save it Then run this one. So in this way you can get the transfer function. So k equal to 10, t equal to simple tf, t equal to eval t, then what will be the answer? Okay, in place of k here, eval t means 10 is written. Okay, that is the only difference. Then we'll write down pretty t. Okay, so this is the function. Okay, so here we will complete today's lecture. Thank you very much. Okay, so how to unlock free plan on Unacademy? So Unacademy Learning app, go to that, install that app. Okay, go to daily interactive live classes, GATE and ESE section you can select. Okay, go to plus subscription, then free crash course on surveying for GATE 2021. Suppose this video course you want to watch it free, then click on this course. You will be asked to put an invite code on the free plan to unlock it. Put the invite code SSM10, then unlock it. Okay, then you are free to watch it. Okay, so like it. Okay, like it, subscribe it, comment on it. Okay, go to our YouTube channel, comment on it, like it, subscribe it, hit the bell icon for notifications. You can also use my code SSM10 for discounts, registration and offers. You can join our Telegram channel for latest updates on upcoming videos. Thank you very much. Thanks a lot.